All right, guys, so here's our first example for the day. Go ahead and copy that down, please. We'll call that example 1. Call it 1A. We're going to have another one in just a second. All right, so before we begin, let's try this. If I asked you guys real quick, don't write this, but just follow along. What's 3/4 plus 1/4? Final answer is 1, right? Because when you add fractions, so long as they have the same denominator, you can just combine the numerators together. 3 plus 1 is 4. You keep that same denominator, and there's your answer. And yes, we can reduce in this case, and we get 1. So same thing applies to these. These are just fancy fractions. That's all they are. So so long as the things that we're looking at have the same denominator, which they do in this case, then we can go ahead and just add the numerators together. So I just need to combine these two things together here. Now, before I do that, though, I think it might be helpful to put these each in parentheses and put that sign in between them. It seems kind of silly, but I'll explain why I think that's useful when we get to our second problem, but for now it's just a good habit to build. But we just combine the numerators and it becomes one fraction. You see how I made it just one big fraction with a common denominator now? All right, so now we can just start combining like terms. So 3x and 3x can go together. That makes 4x, right? And then -5 and -4 can go together. It makes -9. Too bad, right? Now sometimes these can be reduced at the end, but not very often. This is a good note to write. By reduced, I mean you have to factor it and then cancel stuff out. So here's what I'm going to tell you guys. Don't worry about reducing them. It's fine, just leave them. But on a multiple choice test, after you combine, if you don't see your answer, try reducing it after that. Okay? But the reason I say don't worry about it is because like 9 out of 10 times after you add these, they can't be reduced. They just don't reduce well. But every once in a while, there's one that comes up that can be. And it's just factoring is a lot of work, so I don't want to encourage you guys to do all that work whenever, most of the time, it's not going to do anything anyway. So we'll just say only factor if you need to. All right, let's go ahead and take a look at this one. This is example 2A. I'm sorry, example 1A. I'm sorry, 1B. Wow, completely beat that up. Notice that we still have two fractions with a common denominator, right? So the first thing I said to do was to put them each in parentheses, put that sign in between them. You know, I think I want to change the problem a little bit. Sorry to irritate you guys a little bit with that, but I want to do something that will probably be a little more helpful. Can you guys put like a +3 here? All right. So when you're subtracting, you have to do something a little different than we did with the addition. Since there's a minus in the front, you're going to need to distribute the negative. So, and what that's going to do is change their signs. So if they're positive, then they become negatives. If they're negatives, they become positives. So the k plus 3 stays the same. The 2k is now going to become a minus 2k, and the 3 is going to become a minus 3. But after that, you just do it like we did addition, then you combine the like terms. So with addition, just combine the like terms. With subtraction, you have to distribute the negative before you combine like terms. Okay, so k take away 2k is negative 1k. 3 take away 3 is 0, so that just cancels out. And we're going to stop there. If this was a multiple choice test, I would look for that answer. If I didn't see it, I would try to factor and reduce, but that's not going to reduce, I can already tell you. All right, so that is adding and subtracting rational expressions when they already have a common denominator. So let's go ahead and start with that, where we already have a common denominator. That's the nicest situation you can hope for there. So go ahead and try these two. I'll give you guys a second. So for the sake of the people watching the video, I'll write this real quick. This is probably what you got, but this is one of those situations where it does reduce. So let's go ahead and move on to our next one here. All right, I'll go ahead and write this down. We'll call this example 2. So for this one, this is the question you want to ask. Notice how we don't have a common denominator here. They're not the same, all right? So here's the question you want to ask. What can we multiply by to get them to match? All right, so notice the left side has 5x and the other side has 5x to the third power. What would I need to multiply by to get these denominators to be the same? 5? They both already have a 5. So if I did that, it's just going to make it bigger. Don't write this. But you don't need to do that because they already have a 5 in common. We want to make them the same. So which one seems to have more than the other side? The one on the right has more, right? It has x cubed. So what can I do to get this guy to become an x cubed? Multiply it by, not 2x, but you're getting 1. No. If I did 3x, like let's say 2x, let's start there. If I did 2x, that would be 10x squared. That's not going to make them match. So there you go. Okay, so we want to multiply it by x squared. Okay, so, but whatever you do to the bottom, you have to do to the top. So the top here is going to become 4x cubed. The bottom is going to become 5x cubed. Now we have a common denominator, right? Yep, after you get the common denominator, you can just do what we've been doing before, which is add them together. So we could just combine these. No, those are not like terms, so I can't combine them in any way. I'll just put them together like that, and then we're all done. All right, so I'll say it again. If we don't have a common denominator, the question we ask ourselves is, what can we multiply by to get those things to match? Where do we do the bottom? You have to do the top. After you've got a matching, then it's just like what we did before. So let's go ahead and move on to another problem here. We're going to call this a guided practice. So I'll call this guided practice. Now, I want you guys to try to think about something. You need to multiply this side by something so that it has something, so that it will match this side. But this side needs something too this time. They both need to be multiplied by something to match. So see if you guys can figure out what you need to multiply each side by so they end up with the same denominator. Take a minute and think about it. That's the most important step with this example. That's the new part, because the rest of it's pretty straightforward. So take a minute, see if you can talk to your neighbors about it, see if you can figure out what would we multiply by to get those things to match. I don't know. I'll look. I'm not sure. All right, so let's see what you guys got here. Stephen, what did you try to multiply by on the left side here? What does this side need to match the right side? Well, take a look at them. What does this side need that this side has? So this side needs an x and a y. They just need to match. Now that's still not going to get them to be exactly the same though, right? If I do that, this side's going to be 6xy, but this side's 3xy. I need to be 6xy. So Damiani, what would you put over here? Okay, so let's think about it. 6xy, 3xy. What would I multiply this by to get it to match this side? 2. All right, so let's go ahead and put this stuff together. What is xy times 2x? 2x squared y. This one I'm going to rearrange stuff a little bit so it looks more familiar. Jedrick, what's this going to be on the top right? Okay. And Amethyst, what's this going to be? What's this going to be? Okay, and it should be, right? We wanted those to match, so we got them to be the same. So I multiplied the left side by xy, multiplied the right side by 2, and that gets those things to be the same, all right? After that, you could just combine your like terms. Well, there are no like terms, I'm sorry. Just combine the tops together and put them over that common denominator. Now, this is good enough answer, but this is another one of those things where if you were taking a multiple choice test, you probably wouldn't see that answer there because this one can be reduced. What can I take out of the top? You can't take out a 6, but you can take out a 2. If I take a 2 out of the top, what would be left? 1x squared y, yeah, plus 3. Now the 2 and the 6 can reduce. What does 2 over 6 reduce to? 1/3. So this becomes a 1, and this becomes a 3. So that would be the answer you'd see on a multiple choice test, but I'm surprised we've seen 2 of those. Like I said, it's pretty rare for those things to be reducible. So the 1 is here in the front, right? But there's no reason to write the 1, but I did put the 3. All right, so that was a guided practice. So here's a student practice. I reduced 2 over 6, and it became 1 over 3. All right, guys, so here's one for you to do, student practice 2. Go ahead and see if you can get those to match. What would you have to multiply by to get these things to be the same? What does each side need to look like the other? All right. So, Crystal, what do I need to multiply this side by? Okay, there you go. 5 and 2 have absolutely nothing in common. So it's not like the last problem we had where it was 3 and 6. If it was 3 and 6, you could just multiply that one side by a 2 and make them both 6, right? But with 5 and 2, those are completely separate numbers. So in this case, we're just going to multiply this side by 2 and also the y squared. And wherever you do the bottom, you do the top also. All right. Let's go ahead and take a look at the other side there. Armani, what would I multiply this side by?
5x3.
5x3. All right, let's go ahead and simplify those up by adding them together, or not, I'm sorry, multiplying those together. Amaya, what would this be? 2y squared times 5x. All right, so Cal, what would this be? Yeah, it doesn't matter. Multiplication can be in different order. Robin, what would this one be? And the bottom one over here should match the one on the left if we did it right. So I'll just write the same thing here. All right, now, the next thing we would do is combine the numerators together over that common denominator. All right. And I would just stop there usually. But like I said, I'm looking like a liar because I told you it almost never happens, and it's happened quite a bit today. But that's good. It gives us a chance to practice it. This one can be reduced. So here's what I want you guys to do. On the top, I would like you guys to take out whatever you can. Take out the GCF on the top there. I'll give you a second to give it a try. Take out the GCF on the top. What can you take out of these two things? Go ahead. Write it down in your paper, and I'll ask you in a second what you got. Oh, and did you find what you could take out on the top? How about you? Did you find what you could take out on top? Good. That's true. You can take out a 2 and an x and a y. I wonder if that would be good enough. But that's not the GCF, the greatest common factor, but it works. You could do that. 5xy is bigger, but we can go bigger. Yeah. We could definitely take a 10 out of both. And that's as big as it gets for the numbers. How about the x's? So you guys said xy. You guys are both right to say xy. You can't take out any more than 1x and 1y because this one only has 1x to give and this one only has 1y to give. So you can only take out what they can both give. So if I take the 10 out, 10 divided by 10 is 1. And if you take 1x away, this guy won't have an x anymore. So, and if you take 1y away, it will only have 1y left. So this is just going to be 1y. On this one, if you take a y away, it won't have any more y's. And if you take an x away, it'll have 2 x's. Okay? So, I don't like the ones there, though. We don't typically write ones like that. So I'm going to rewrite it without the ones there, but it helps when I'm explaining it. I'm going to get rid of those ones. Now, I'm going to slide this over a little bit so it's a little bit easier to see, but this can be reduced. See if you guys can reduce that real quick. We have 10xy over 10x squared y squared. So so you're noticing that I can reduce by 10xy basically, right? So let me ask it this way then. What will be left on the bottom? There you go. So let me explain why in the bottom is x squared y. First of all, the 10's go away. This x on the top takes away one of the x's on the bottom, so we're just left with x squared. This y on the top takes away one of the y's on the bottom, so now I'm just left with y. So we reduced. So once again, I'm going to stick to my guns on this. I just think it's some weird random chance. I think it is more common with these types of problems where it's one term everywhere like this, where they can be reduced in the end, but usually they're not. But there it is. All right. I had more planned, but I think this was a little bit challenging for you guys. So what I'm going to do is I'm going to stop the lesson here. I'm going to change the homework, though, so we practice these two types. So let's look at what we've looked at so far today. We've looked at problems that already have a common denominator. It's really just combining like terms. That's it. Just combine like terms in the top and you're done. But don't forget, if it's subtraction, you have to distribute the negative before you combine like terms, right? After that, we looked at these types of problems where they don't have a common denominator. We just have to ask ourselves, what do I multiply by to get these things to match? After that, it's pretty much the same. Last note, sometimes you need to reduce at the end. So how will you know? Don't worry about it. Basically, on your homework, you don't really need to worry about it. I would say look for it. Try to reduce. If something catches your eye, like, oh, I can reduce that, then go for it. But if not, no biggie. But just know that on the test, if you don't see your answer there, maybe it's because it needs to be reduced. Okay. So that's it. I think I'll kill the lesson there. I'll upload the homework in about a couple of minutes. I would encourage you guys to start the homework in class and practice a little bit, because this was kind of a tougher one. We're going to build on this stuff more next time. We'll continue adding and subtracting rational expressions next time.